Perfect. Is there a clicker? Okay. So thanks everyone for being here bright and early Monday morning. This is a really great group, and I got to know all of your names and your applications looking through them, as did many of the other faculty, and it looks like you're doing some really interesting work. I gotta say, like, I didn't become an economist because I was interested in economics. I became an economist because I was interested in cities, and I thought economics was the best, most appealing sort of framework that I found to think about cities and the operation of cities and how to make cities work better. And I could see in the application materials that all of you put in that many of you, all of you have interest in cities and see and have this fundamental applied interests. And that's really, that was really exciting. One of the things about the field of urban economics that I love is that it's pretty methodologically agnostic, unlike some other fields. And so I think that's been a big source of its revival as a field, because you have lots of openness to ideas coming in from other fields in terms of methodology, in terms of data, et cetera. And so I hope in talking today about housing supply, some of these ideas come through. This is based on a chapter that Gilles Duranton and I wrote for the forthcoming handbook on regional and urban economics. So it will be coming out in August. So I encourage all of you to take a look at the different chapters in there. Adam has a chapter, Adam Storgard, as well, about data in urban economics, and it I think gives us some sense of where at least parts of the frontier are in the field. Okay, so and I'm going to go for about an hour, then we can take a 5-minute break, and then we can come back to it. I want to also say that if you have questions or thoughts or comments, I encourage you to raise your hand or just speak up. And it's always more interesting to have a bit of a conversation during lecture.
We're going to try and sort your lapel mic, but we're going to try and sort you a lapel mic.
Okay.
But if people are going to be able to hear you on the recordings,
I got to be here.
Stand there until we've done.
Okay, gotcha. I'm a wanderer, and so I'll have to
chain yourself to the lectern.
Okay. Okay. So one big policy challenge that we face, not just in the U.S. but really around the world, is the decline in housing affordability. And so I want to think about sort of what we know about this, and then get into talking about housing supply and the extent to which constraints to housing supply could be responsible for declines in housing affordability, and also sort of walk through different ways in which the literature has thought about different aspects of housing supply. Okay, so that's kind of what I'm gonna try to do in the next few hours. I think there is a broad recognition, supply and demand will tell us that when supply is inelastic and demand is growing, prices are going to go up quickly. That's not very controversial, but I think there's a lot of nuances still to understand that requires thinking about space and the fact that we have different markets, and that housing supply fundamentally is a dynamic phenomenon. You know, it gets built and then it's housing gets built and then it's there durably for many years, and it's hard to redevelop. Why that is. Also, housing is a differentiated product. There's big houses, single family homes, there's small apartments. Understanding how that fits into this affordability question is important. And of course, on the demand side, we have a lot of heterogeneity, right? We have high income and low income segments of the market. And we have tenure differences, we have renters and we have owners. So all of these issues make the operation of housing markets more complicated than just the operation of other types of markets. And I'm going to be talking mostly about housing supply here, but I think there's going to be some demand side stuff that sneaks into, especially when I talk about assignment. Okay, that's going to be important. Okay, and so I want to start by just laying out some facts about trends in quantities and prices and affordability, and try to point out kind of some of the things that we haven't really come to a good grasp of in the literature within these facts, with the idea that I think there is a lot of research potential thinking about these issues. Okay, beyond affordability, of course, having a better understanding of housing supply helps us understand price dynamics. So there's a sort of an asset pricing element to our interest in this topic. Jesse Gregory is going to talk about sort of place-based policies later. The extent to which there's supply responses to local demand shocks associated with place-based policies is going to have a lot of implications for who garners the rents of those policies. And of course, we have a large segment of the housing market that's subsidized, and there's a lot of policy questions there. And there's a lot of questions about how much and where we should build new infrastructure, the extent to which supply can respond to the demand growth or the changes in the spatial distribution of demand that comes with new urban infrastructure. In order to understand that, we need to understand something about supply. Okay, and also, in order for cities to grow, they've got to provide more housing. Okay, and so supply comes in there as well. So this is really, I think, one of the fundamental sort of issues in urban economics is understanding how housing gets provided and thinking about these things. Okay, so I want to show you some facts. I'm going to focus on the US. I think there's a lot of really interesting work that has been done and yet to be done about housing and infrastructure in the developing world. Melanie Morton will be here on Wednesday to talk about that some. But I'm not going to do that here. After talking about these facts, I want to sort of work through your kind of standard production function estimation for housing, and see what we learn from there. And I think there's kind of a few nice observations that come out. One is what I like to think of as the grand constant of housing supply, 0.65, which is the capital share in housing production. It seems like a pretty robust, thank you, pretty robust result in the literature. And I think that part of things has been pretty well established, sort of static production function estimation for housing. There's still some more to be done, but I think we have a fairly good handle on that. But what we don't have a great handle on so far, and there's a lot of active research on, is dynamics, and how real options matter. That is the incentive for developers to wait to build, before more information about prices and demand conditions are revealed. The fact that housing is a differentiated product and there's a matching process between households and housing units, how much that matters, so-called assignment models, and then thinking about general equilibrium models, and the fact that there are various feedbacks between different markets, labor markets, housing markets, et cetera. And this can matter, and that's fundamental, to urban economics, thinking about these things. Okay. And sprinkled through, I'll try to mention various policy relevancies as they come up. One of the big observations that's made in the housing supply literature is just, it seems like the productivity in housing production has been actually falling over time. And there's a bunch of research now trying to think about this issue, and I think we really don't have a great handle on it. Okay, so that's one issue, and then there's subsidized housing policies, and there's lots of policies, of course, in terms of encouraging home ownership, tax incentives for encouraging home ownership in various ways that will come up as well. Okay, so here's kind of the overview. And this chapter, by the way, you can find it on my website. Okay, so I want to give you some facts about housing costs, more carefully indexed prices, quantities, and then spatial patterns of supply growth across the US. To start, I just want to look at, I think this is something one should always do when starting an empirical research project, no matter what it is, just try to look at the most unfiltered data possible. And so I want to show you what's in the Census and American Community Survey data about housing value, self-reported housing values and rents as compared to incomes, how they've changed since 1980. And I'm going to show you four kind of, you could broadly defined markets. As a baseline, I'm going to show you this evidence for small metro areas and rural areas, with the idea that these are the types of markets where building should be the easiest. You have the most land available for development. If there's any place where housing supply should be elastic, it should be places like this. These are the places that should be the least constrained. Now, of course, they probably also have the lowest demand growth, okay? But nonetheless, I think there's going to be some baseline patterns we see out of these small metros and rural areas that are a useful basis for comparison to suburbs, which have had pretty rapid demand growth, but also at least 40 years ago, a lot of land available for development. Central cities that have had weak demand growth, but not a lot of land available for development, and so-called superstar cities, which have had relatively strong demand growth, but also constrained supply, both for regulation reasons and land availability reasons. Okay, so just to kind of fix notation and set the accounting, we can think of households consuming little hj units of housing services through their dwelling, defining J to index markets. And then we can aggregate to big HJ as the market level quantity of housing services, okay? The way we want to think about a market here is that within a market, each unit of housing services is a perfect substitute with price PJ, with every other unit. Now, that's never going to be the case exactly, but clearly these large definitions, large scale regional definitions I gave you on the prior slide we don't really technically want to think about these as markets. We want to think about much more local areas, and I'll show you some evidence using census tracts later. But in order to lay out some facts that are kind of manageable, for now, we can think about markets as these broad areas. Okay. And what's going to matter then is the trends are similar in the different markets within these broad areas. And aggregation is an issue, and I'll come back to aggregation later. Another issue, of course, that comes up with studying housing is that in data sets, we tend to see sales prices, transaction prices, or maybe self-reported values. And what are they? They are prices times quantities, right? So PJ times HIJ in this notation, okay? And so, and the quantities can change for various reasons listed here. Okay, so basically this affordability challenge that we face, it's a real challenge. It's not a mirage. I'm afraid to walk away from the mic. So this is what I should do. I should use this. Okay. So this is all of these plots are indexed to small and rural counties in year 2000. Okay. And this green line is household income. And then the red line is self-reported rents. And the blue line is self-reported values. You see, even in these places where it should be easiest to build, incomes have not kept up with rents and values, though most of the divergence is between 2000 and 2010. Okay. In suburbs, these intercepts are higher up off the axis because they're all indexed to 100 for small and rural counties. And you see, if anything, even more divergence. And you see a lot of, very large cycle with the great financial crisis and the recovery in the housing market from the great financial crisis. And the end here is COVID. And especially in suburbs, housing prices really exploded during COVID with the kind of spatial shift and displacement in demand for housing to suburban areas. Okay. In central cities, you see actually relatively low incomes, but very much the same pattern in terms of divergence between housing costs and incomes. And then in the superstar cities, these are cities where it looks like supply is quite constrained through regulation. You just see this enormous growth in self-reported housing values. And I'm going to show you indexed versions in a second, and they're going to look very similar. Okay. So this is kind of the state of play. And it's really quite striking how really only since 2000 has housing affordability become a huge challenge. Okay. And I'm going to show in a second that also only since 2000 have construction rates for new housing units fallen precipitously. Okay, which, and it's not surprising the two would go together, right? And this seems like, at least in the US, sort of a national phenomenon. Okay, so you might say, hey, part of the issue of what you just showed was over time, new housing units get built, new housing units are higher quality, or maybe even existing housing units get renovated and they become higher quality. And so you're not holding the quantity of housing services constant over time. And that's why the self-reported values and rents have been going up. And maybe it's not really a problem. It's just that people are becoming higher income and consuming more housing as a result. Okay, so you haven't properly indexed. Okay, so for housing prices, we have various options for repeat sales indices that hold quantities constant in some way over time. The FHFA price index is one of them. And what's nice about it, it comes at the census tract level. it has the disadvantage of being only for single family homes with prime mortgages. But it's sort of the best national data we have right now on this. And I was actually talking a few weeks ago at the American Real Estate Urban Economics Association meetings to one of the people who was really instrumental in putting together this index, Will Durner, who unfortunately was laid off from he was doged along with his whole research group. And they're trying to cobble together what they can to keep this index going. And I hope they're successful, but you know, people working in government trying to create statistics for us, they do matter. And that's an example. Zillow has a rent index that's a repeat rent index that they put together as well. Okay, so I'll show you that, but that's much more recent. And then I want to compare that to construction costs with the idea that one of the reasons that housing prices might be going up is that to the extent that new construction matters, new constructions might be more costly, and indeed they are. Okay, so if we look at the same regions as before, once again indexing to small rural in 2000, basically the prices look very much, the price and rent series look very much like the value and rent series from before, but the construction cost index has this sort of kink in 2005 and really starts rising much more quickly after 2005. And I'll come back to talking about some ideas out there in the literature about why this might be the case. I don't think we have a great consensus about why this is the case, but it's very clear in the data, okay? And this is no matter whether you look in rural areas, suburbs, central cities, or superstar cities. But if you look in suburbs to some extent, in superstar cities, really quite obviously, values are still, or sorry, prices and values are still rising much more rapidly than construction costs. And that points to a land availability slash potentially regulation issue, that it might be just there is not very much land available to be developed, or basically, even if you can develop land, you can't build high enough to accommodate demand, okay? Build tall enough to accommodate demand. I'll come back to some of those ideas a little bit later. And that's gonna make prices rise more quickly than construction costs, okay? This lower line here is just the CPI, and it's the same in all four of these diagrams, and you know, clearly housing costs are rising faster than general prices. Even it's a little bit hard to tell because there's so much volatility, but it looks like even in the small and rural counties, okay, where the land availability should not be an issue. Okay, so that's sort of an overview of prices. Affordability is becoming more of a challenge. Now I want to look at quantities. So quantities can change through new construction for sure, but they can also change, or one thing that influences quantities is how rapidly existing housing units get taken out of the stock, basically depreciate away or allowed to depreciate away beyond usability. So I want to have a way of depicting trends in quantities that sort of allow us to look at both. Okay, so I'm going to show you a cohort analysis of housing units that existed in the stock in 1980, 1990, 2000, and 2010, and kind of follow those cohorts over time to see the rate at which they were taken out of the stock in these different types of markets. Okay. Same indexing, but here for this sample, but I'm going to actually index all samples to 100 in 2000 because now we're talking about quantities, and there's huge quantity differences across these different types of markets. Okay. So what you see in these small and rural counties, where it should be relatively easy for developers to respond to demand growth, is if we follow this cohort of housing units that existed in 1980, the depreciation rates or the teardown rate is pretty constant over subsequent decades. And that's true for housing units that existed in other decades. And you can see the amount of construction in say the 1980s by comparing these 2 points here. Okay. And yes, it looks like the construction rate went down a bit in these small and rural counties over time, but that's largely because population growth, which is this yellow line, declined over time. This is a weak demand places, but otherwise, things didn't change too much. And depreciation rate of 0.7% per year you can think of it as kind of a baseline. In the suburbs, something did change. Okay, so in the suburbs, especially in the most recent decade, basically the teardown stopped, and that ended up accounting for, relative to prior decades, an important component of the supply growth. Okay, these blue lines are basically flat between 2010 and 2020. Okay, even though population growth kind of continued apace. I guess the other thing I should mention is that there is a bit of a misconception, like in these rural areas and even in these suburbs, there has been enough housing construction to keep up with population growth, even a little bit more than that. So one source of demand growth has been declining household sizes, which if you look at the number of kids in your household relative to your parents' household is kind of comes up pretty commonly to be a lot less. So the composition of demand is changing, and I think seems like towards smaller housing units, and yet we have a lot of legacy housing stock that is very large houses, right? And so I'm going to come back to those ideas a little bit later when we talk about assignment and filtering. In central cities, you see much lower population growth, but also this same phenomenon that depreciation or teardown rates basically stopped after 2010 and started off a little bit lower. And in these superstar cities, basically there's almost no housing being taken out of the stock. But these cities have been actually doing in the most recent decade quite well at building new housing in a way that suburbs and rural areas have not. And I'll show you that in a different way in a second. Okay, so there's something going on here that's very clear in the data that housing construction costs have gone up much more rapidly than before, much more rapidly than prices, other types of prices. And now we're at a point where it seems like in order to provide new housing, a really important part of that is to keep existing housing in the stock longer. Okay, and depreciation rates appear to be related to demand. So in high demand locations where it's hard to build new housing, you're just going to have fewer teardowns. Okay, and so then I want to look at density and as a function of location. Okay, and what I'm going to show you is that after 2000, especially in the suburbs, there's been a big reduction in construction and in density growth. And suburban areas have started to hit up against so-called density ceilings. And there's a lot of work recently about minimum lot size zoning and the importance of minimum lot size zoning to help understand that and think about the consequences of this sort of density zoning. Okay, I think there's a lot of consensus that there are a lot of benefits associated with infill development, but suburbs are finding ways to keep this from happening. In the cities, we kind of almost have the reverse going on. We have more rapid densification going on than before. Okay, so I'm going to give you some graphs of densities against and also the Wharton regulation index over time. Okay, so this is all metro areas. The red lines are for central cities, and the orange lines are for suburbs. And this is an index of distance to the central business district. 1 is the farthest location from the central business district that's within central cities. Okay. And what you see for this, and so some suburbs have inner suburbs, like Medford is closer to the CBD of Boston than the outskirts of the city limits. And so Medford, where we are now, would be kind of in this region here. And so what you see is that in the suburbs, you have this density growth that was much more rapid between 1980 and 2000 than 2000 and 2020. Okay. And that's also true in the suburbs of superstar cities, though those suburbs are about twice as dense, have about twice as many housing units per square kilometer as other suburbs, suburbs of all cities. But in central cities, you see, at least for some range of CBD distances, quite a bit of density growth that actually has been greater between 2000 and 2020, which is the top line, than the prior 2 decades. Cities are starting to figure out how to permit and facilitate the construction of, especially if you look at the data, multifamily housing. And this is a new phenomenon. So I live in Toronto, Canada. Toronto in North America has been by far the most successful at doing this. There's been hundreds of thousands of condos built in the past 10 years. That's because in Toronto, the permitting regime is such that the city denies, just like in US jurisdictions, denies permits for large-scale construction in most cases, but the province has the legal right to overrule the city. And that's not true anywhere in the US or in most other countries around the world. And that seems like a big part of the story to help us understand why there hasn't been more of this going on. Because the demand, especially in superstar cities, is there. Okay. These blue lines are the Wharton Regulation Index. And this is just to show that they've been rising over time. It's a measure of regulation. It's not the only one you could have, but it's been rising over time. Okay. And I guess the other thing I'd point out is, a lot of the local opposition to densification comes from this idea that there's going to be congestion and negative externalities associated with the new residents. And yes, probably that's true. But in these superstar metros, housing unit and population densities are about twice as high as in the typical metro. So there's a lot of scope for densification. We know how to handle dense urban environments. We know how to provide the needed infrastructure, but it's not allowed to happen in a lot of places. Okay. All right, so that's an overview of the facts. And I think, there's now a lot of research interest in understanding why these rates of new construction have fallen so much. It clearly is related to the fact that housing costs have increased so rapidly. And so as a first step to get a handle on this, we need to understand something about the economics of construction. Okay, so that's what I want to talk about next. Okay, so if we think about supply elasticity, or the response in the total quantity of housing services to price change in the market in percentage terms, we can decompose that into kind of extensive and intensive margins. So this is the amount of the response of the quantity of housing units, housing services built to a price change for a developed lot. And this is the amount of lots that are developed, or the land development margin. Okay. So this is just a simple decomposition, but this is a very long run decomposition. I think the way to think about this decomposition is to say, if you have a clean slate in 2 locations with different demand conditions, we want to think about how much is built in each location. on the intensive and land development margins, then we can use this decomposition to kind of tell us that in some very, very long run equilibrium. Okay. In practice, there's a lot of frictions to land development, right? So a lot of this, these lots that sort of in the very, very long run equilibrium, you know, you'd say should be developed, don't get developed in practice. And so in the short or medium run, we can decompose the total housing services supply elasticity between period T and T prime into these various margins here where we have the same two, but we multiply by kind of the probability that a lot gets developed. And essentially the development margin, which might depend on developers waiting to develop because of dynamic considerations. I'll come back to that a little bit later. It might be relevant because of regulation, and it might be relevant because of the fact that there's existing development and then demand grows, and then there's various frictions to redevelopment. Okay. So for now, what I want to really focus on is this margin here, that is the conditional on development, how a developer decides how many housing services, how many units of housing services to put on a lot. Okay. And so this has been thought about for decades. And I just want to remind you that we're thinking about there being we're being in a market J where there's some price, big P, of housing services that developers are acting on, okay? But in the data, we're only going to observe information about prices times quantities or expenditure. And so that leads to kind of some practical problems about empirical implementation, okay? Another practical problem is you often don't have information and data sets about land prices as separated from capital inputs or labor inputs. And then you have the fact that there are many, many different markets, and how you define a market might be super important because you want to have a definition where you can be reasonably confident that prices are constant within the market. Okay. And then there's lots of unobserved differences across parcels. Okay, so you have all sorts of selection issues of which parcels get developed. The easiest parcels to develop are going to get developed because parcels have different just fundamental attributes about them that provide variation in the cost of development. Okay, so if we look kind of like the sort of standard builder's environment, we're going to think about parcels being delineated, a builder chooses whether to build, and then conditional on deciding to build, they decide how much to build. Okay, so here's the profit of associated with developing parcel I in market J. It's going to have price per unit of housing services. Developers are going to install capital on some delineated parcel size, Li. We typically think about it this way because this is the way most development happens now. I think this is not exactly the model you would want to use to think about the Levittown suburban developments where developers would buy up enormous tracts of land, basically as much as they could get their hands on, and then build houses on it that are separate housing units. Okay, this is a little bit more manageable than that. Okay, I think we can extend this to that framework, to that environment. But for now, let's just think about developers atomistically developing lots one at a time. Okay. there's going to be some capital that has to be installed with a price, and then there's going to be a land value or a land cost, Q of Li, and there's going to be a fixed cost. Okay, so one of the big differences that shows up in a model like this from a typical profit maximization problem is that the land cost or the land price is going to be endogenous here. So we tend to think of developers as being competitive, and there's some Ricardian rents associated with how much they can develop on the land, and sort of all the rents are going to end up going to the landlord, the land owner that sells the land to the developer, and the developer is going to be making zero profits in the end. Okay. So, and I like that because I'm from Chicago, and what I learned in grad school is that nobody makes any profits. I think that view has changed in Chicago now, maybe, but when I was there 20 years ago, we never saw any profits anywhere, which was quite amazing. So first order condition, optimization over the amount of capital, and then we have capitalization to land values. So basically, it's got to be that the price of the land, the price of the lot, is such that the developer is optimizing and making zero profits. Okay, and so you get this condition that's fairly intuitive, that the land share of production times the revenue is associated with selling the building minus the fixed cost is the value of the land, okay, before development. And that can also be expressed as its dual from the cost minimization problem, where the variable cost times some increasing function of the land share is dissipated into the land, into the value of the land. Okay. This is just to be clear about the construction of units of housing services. This says nothing at all about how those housing services are split into housing units, into dwellings. Okay. In order to understand that, we need to put the demand side of a model down as well. Okay. And I think we really don't have a great sense yet of how to do that in a reasonable way. Okay. So housing production, if you take a simple Cobb-Douglas with capital share alpha, what you will find is that the housing supply function looks like this. Sorry, this is TFP, and this is land, okay? And the elasticity, the intensive margin elasticity of housing supply is alpha over 1 minus alpha, okay? So the higher the capital share, the higher the elasticity of housing supply. I'm going to show you evidence alpha is about 0.65. That's the golden number of housing production. So the intensive margin supply elasticity ends up being about 2. Okay. This is intuitive. If capital, we've assumed, comes at a fixed price. And so if the capital share is high and the land share is low, it's going to be easy to build a lot in response to a demand shock, and supply is going to be very elastic. The constraint here is the land availability. Okay, and that's why a lot of the research on housing supply has focused on the land availability margin, or the variation in land availability is a key sort of force that generates variation in housing supply elasticities across markets. Okay. There was a time years and years ago that people would try to run regressions like this. This is obviously going to run into various problems, quality bias, unobservables that are correlated with local productivity. in housing production, et cetera. So we tend to think, we tend not to run regressions like this anymore, but in theory, with this very simple setup, you could do that. There's this challenge, of course, in implementing even a regression like this, that it's very hard to observe land values. Land is observed with structure almost all the time. And so you need a particular empirical setting in order to do this. There is this paper here, these two papers here that actually do have high quality data on land values. And I'll talk about this paper in more details in a second. Okay. One approach, sort of the macro approach that has been used, is kind of just calibrate shares, assume constant returns to scale production in housing, which actually there is now evidence for. But when this sort of thing was being done, that was more sort of taken as given. And then you can calibrate, the fraction of value that goes to land, capital, and labor, and you get numbers that look something like this. Now, I think this land share is a bit low here, but there, you don't get crazy numbers, and it's kind of a reasonable thing to do for like calibrated sort of macro approach. Now, of course, you have this identification problems when you do it this way too. I mean, basically, you're kind of like running a regression, like I showed you before. And you could have quality bias issues, et cetera. Okay. There is a little bit more recent literature that tries to run estimate constant elasticity of substitution production functions that might look something like this in capital and land, estimating elasticity of substitution with regressions like this on where capital is the cost of construction absent the land, and then the land is L is the say square feet of the lot or something like that. Okay, regressing that on the price of the lot, and land prices and capital investment, are going to be jointly decided if you have a particularly high demand location, then the land is going to be valuable and you're going to put a lot of capital on the land. Okay, so you kind of have that problem. The other thing is that you have this issue that there's going to be potentially like sort of unobserved heterogeneity in how easy it is to develop different lots. Okay. And so people have tried to do this sort of thing, papers try to do this sort of thing, have gotten numbers, lots of different numbers in this elasticity of substitution between almost 0 and more than 1. Okay, so, and there's been various work trying to be more flexible, really instrumenting with demand variation, like amenities, to try to deal with identification problems, and there's been some progress, but I want to talk about kind of where the literature I think has ended up on housing production now, which is this paper by Combs, Duranton, and Gobillon, and it kind of takes a neoclassical approach to non-parametrically estimate housing production technology. Okay, so we have a first order condition from profit maximization, and we have a zero profit condition. Okay, and the problem is in the data, we observe prices times quantities. So we need to use, but what we can do is we can put these together essentially to get rid of the price. Okay, and you get this differential equation, which is very intuitive, which says that the responsiveness of the unobserved quantity of housing services built or developed to a change in percent change in the capital input is just the capital share. Okay, So this is like saying that at a very local level, for very small changes, all production functions are Cobb-Douglas, right? And then what you can do is you can take that and solve the differential equation for the housing production function non-parametrically, basically by integrating over the capital shares installed on integrating up over the amount of capital installed. So you look at basically integrate up over each value of capital, discretize in the data and look at the capital shares, and then that will give you the non-parametric estimate of the housing production function with a constant of integration. Okay. And so in this paper, Combs, Duranton, Gobillon, they use data on construction costs, land, and the land price, which they have essentially to recover H separate from P, and not using this procedure. And then they can kind of characterize the production function by regressing H on K for different lot sizes. Okay. Now, I want to be clear that this is, you don't get identification for free. Okay. You worry that, so what you'd like is, okay, two lots, they're the same size. On one, you see more construction than on another. You'd like that to be the case because demand conditions, basically the price PJ is exogenously different because of demand differences. But it could be that there are land quality differences. And so some lots are more expensive to develop than others. And we want to, and that's bad variation. And we want to kind of take that variation up. Maybe there are labor cost differences too, and that's another source of sort of bad variation. So what they do is they take information on land values or land prices and construction costs and plot sizes, and they kind of fill them in on a grid. Okay, that fills out the data for them. And then to deal with the partial heterogeneity, what they want to do is just get variation in each of these things that comes from demand side variation. So they want to strip out all of the sort of cost variation. Okay. And so they use, this is sort of like a control function approach. They're going to regress these things on supply and demand factors, and just predict out for the average values of Y, the supply factors, using variation in the demand factors for identification. So that's a control function approach that is used in various ways throughout the empirical literature. And what they get out of this is a share, there's the magic number, share of capital that's 0.65. And an elasticity of substitution is close to 1. That is so close to Cobb-Douglas with a capital share alpha of 0.65 and an intensive margin supply elasticity conditional on development of about 2. Okay, so I think I said I would take a 5-minute break. So I think this is a time for a 5-minute break. And we'll come back and talk a little bit about what else we can do with housing production, now that we know that it's Cobb-Douglas.
Thanks for having us. We had a very long
All right, great. So I have the lapel mic now, so I can wander around. So that makes me feel much better. If you have questions or comments, I encourage you just to yell it out. I might not see your hand. I don't have great eyesight. But now that I can wander amongst you, maybe I'll do a little bit better with that. Okay. So we kind of have, I think the best evidence we got is it's a reasonable approximation to have Cobb-Douglas housing production, capital share of about 2/3. So what can we do with this? Well, one thing we'd like to understand is how much potential there is to build up, okay, to build tall buildings. And we do see in the data that you look at many cities around the world, they've really sprouted up tremendously in the past 50 years or so, okay? And this is about 10% of building volumes in some cities around the world. And so there's been some work on this to try to understand kind of what the production technology looks like for tall buildings. And this literature tends to look at, that has data on building heights, called that G, which is the ratio of housing services to land, okay? And as sort of estimated this parameter, which I call theta here, which is known as the cost of height, the elasticity of unit cost to height, which in a Cobb-Douglas world is just the inverse of the supply elasticity, okay? And has been found to kind of match up pretty well kind of for the average building. This is work by Alfeld Macmillan, for example. So what's nice about this, I think, is that we can even use this sort of framework to think about really tall buildings that require a lot of engineering, okay? And not just single family homes. The production technology estimation paper I just talked about was using data on single family homes only in France, okay? So there's a few differences though. So one is prices empirically depend on height off the ground. So the height elasticity for prices is, 0.05, something like that. And theta, the construction cost, or how the elasticity of unit cost to height, does depend on sort of the attributes of the lot, including in particular bedrock depth. And so this variation in bedrock depth is something that does generate some supply side variation in city aggregate heights. So I have a paper looking at this. And then there's also, this goes into regulation, that there's been a bunch of work looking at in various ways the fact that it looks like cities, the large cities around the world, are height constrained in various ways. So one way of seeing that is to look at a so-called regulatory tax, and that is to look at the price of the marginal unit of housing services, or marginal square foot, relative to the cost of construction. And for example, Glazer, Jerko, and Sachs finds that that ratio is about 2 in New York City, which looks like a pretty high regulatory tax. Okay. And even higher in London. Okay. So I think I'll just breeze through this. There's various different types of ways, looking at bunching, looking at floor area ratio limits or regulations, that using a production technology that's kind of reasonable, that we've estimated, you can kind of infer from that there's less height that's been constructed than is justified by demand conditions in a lot of cities around the world. And I have a paper that uses a quantitative model to kind of evaluate how much higher welfare would be were we to get rid of height restrictions around the world.
G here is height and not just density, because we're only looking at center cities in this case, or
so this is at the building level, what the height of the building is. Okay. Yeah. So and that data is out there. Like it's now it was in Porous, but now it's CoStar. It's part of CoStar. It has like at the building level for buildings around the world what the height is. And so that's because that's the data that's available. You know, it's nice to set up your model so that you can use it. And then there's this productivity issue in housing. Okay. So this is like kind of a famous graph now, I think, from Goolsby and Syverson's NBR working paper that shows that the value added per worker in construction and this one, there we go, has been going down since the 60s, as has TFP, and these are for the economy overall. Okay, and there's I think a lot of thinking now about what's going on here. How do we understand this? Okay. It's like, so I took the green line out here today, and it costs like $2 billion or something to build like 4 stops on the green line, right? So maybe it was only $1 billion, I'm not quite sure, but it was a lot of money. And that's like order of magnitude higher than what it cost 100 years ago to build these things in real terms. Similarly, comparing the cost of building One World Trade Center to the Empire State Building. Okay, and so this seems like a productivity issue, and we saw the growing construction costs data from RS Means for single-family homes. It seems to be all over in the data. Okay, this is there's a little bit of thinking, especially Joe Jerko has done a lot of work thinking about these issues. Okay, a little bit maybe unionization, they're getting some rents here. Maybe there isn't as much innovation as there could be in the construction industry, though it's not that different from other industries in some ways, in terms of like materials, for example. But nonetheless, like the way a house or a building gets built today is very, very similar to the way it was built 50 years ago. And that's not true with most other products we use, like cars, okay? And so there's this working paper by D'Amico and Glazer and Kerr and Jerko that think about this issue, and they really argue that land use regulation is a key force here, that because every jurisdiction has different bespoke, detailed zoning codes and processes for navigating the planning system, that is very hard for firms to operate, developers to operate in multiple jurisdictions, and that keeps them small, and that means that they don't have an incentive to innovate on how to build large-scale developments.
So the issue is that they'd like to build bigger to scale, which is more productive. And it's the towns that limit them to smaller size production that forces them to produce unproductively.
It's partly that, but also that each town also has its own regulatory regime. So I think it's some of both that they're arguing, right? But what I've wondered, honestly, I think there's good work to be done here, is how much of this decline in productivity is also because, as Jeff says, like you have now much more, you have a situation in which the large tracts of land in suburban areas of US cities where there was high demand for living after the highways were built, and with suburbanization has kind of been built up now. And now there isn't a lot of really there's really very few places where you have a lot of land available for development that could be developed at scale where someone's willing to buy all those homes.
I told them to compare across the US because there's heterogeneity. Think of Houston, Texas.
Yeah,
where it's much easier to build.
and there is some of that still in Dallas too.
Right,
In
and
the
I would guess
suburbs.
that productivity is somewhat higher in Houston,
Yeah,
because they can build to larger scale, maybe fewer, more productive developers in Houston versus Boston, for example, would be something that they could look at.
yeah, but they hadn't, I guess, is that right? When you.
They had not.
Uh,
I told them to do it though.
Okay, well, we'll see. So I think this is, this is an active area of research, right? Trying to understand what is driving this productivity decline. Okay, and how much is explained by regulation, by land availability, and also by the fact that a lot of the construction we see now is about maintenance of old homes. And maybe that's not what we want to count in our productivity measure for construction. We want to talk only about new construction. Okay. There's a lot of work to be done, but I should move on because I only have an hour or something. 40 minutes. Okay. So durability. So now I want to think about different parts of the frontier about housing supply, sort of in different dimensions one at a time. Okay, and so the first dimension I want to think about is durability. I think durability and dynamics of housing supply as a topic to work on has had a very successful job market paper track record. Most of the papers I will talk about were job market papers, okay, including Alvin Murphy's, and Alvin will be, talking tomorrow. So the big kind of issue about durability, right, is that there's this potential, this option value of waiting. That if you don't build now, you potentially have the opportunity to build in the future when market conditions are revealed, and that can actually turn out to be a higher profit thing to do. Okay, so you give up some rents now, but maybe you can better optimize in the future if there's uncertainty that's going to be revealed in the future about the state of the market. And a lot of developers do this. They buy up lots and sit on them for years, waiting to build when they know what's gonna, when they're more sure about the state of demand for these lots. So this option value of waiting, Sheridan Titman talks about this in the AER paper in 1985. And so I want to think about sort of the simple standard two-period model, and then we can see where the literature has gone from there. So if you have two options as a developer, develop today, or develop next period. Okay, so developing today, you install K0 units of capital. You're going to get this profit. You're going to get to rent it today for P0, and you rent it to tomorrow, next period for expected value of P1, and you got to pay for that capital. And so the sort of indirect profit function looks like this when you do that. It looks like this because basically where these things are together, because the amount of capital that's been installed is fixed. You build and then you're stuck with that building size. Okay, and if P1 is really high, then maybe you've underbuilt, and there's sort of implicit costs there. Okay, so if you develop in period 1, then you don't get anything today because you're not able to rent out anything because you haven't built it yet. But you're going to get some expected profit from the perspective of today that depends on the price tomorrow in a way that looks like this. Okay, so you see that if alpha is 0.5, that would be P1 squared, the expectation of P1 squared. Okay, so if prices are rising or if there's uncertainty in prices, there's going to be a reason to delay because you can kind of build to market, more to market tomorrow rather than underbuilding today if prices are going up, or potentially you have that option if prices are going to be very uncertain tomorrow. Okay, so that's the idea of the real options. And so you can see the trade-off here between getting that stream of rents today and getting the sort of potential high prices because maybe P1 has a high variance tomorrow. Okay, and that gain from delay depends on the variance in P1 rather than its mean. Okay, so we can add multiple periods and make it into a problem set that you spend the weekend agonizing over, but that's the idea that's going to be coming out. Okay. Okay. So now we talk about job market paper topics. We think about an infinite horizon framework. Okay. Think about a market, and this kind of looks like Alan Sau's paper about Jakarta. Okay, about development and redevelopment of tall buildings in Jakarta, where you have climate sort of sea level rise affecting the viability of these buildings and an incentive for the government to kind of protect these buildings. Okay, so if we have initially big L here, undeveloped parcels, and over time we're going to build up these undeveloped parcels. D is the number of developed parcels. Okay, and then for the undeveloped parcel, you either wait or develop, and if you develop, you've got to decide how many units of housing services to develop, and that's irreversible. Okay, so that's HIJT, and those are going to be sold each period for big P, for every period that the construction is in place. Okay, and then we'll have our Cobb-Douglas cost function, okay, and a fixed cost. That's IID and drawn from a logit distribution. Okay, this is a pretty common thing to do, is have these fixed costs that are kind of stochastic, that kind of smooths things over in these models. Okay, and so then the housing stock is going to evolve like this, where we're going to build up this many units of housing services every period, depending on how many lots are developed and how intensively they're developed each period. Okay, so we're going to have value function that depends on the max of, this is for a developer, the max of whether they don't develop. If they don't develop, they wait a period, they discount by a period. That's what this is doing. And then they have a sort of new value function for next period that gives them the option to develop then. And if they do develop, they're gonna, the value they get depends on sort of how much they choose to develop, H, okay, and we can write their kind of profit like this. This is a very simple setup. We're just going to say that sort of the price they get, which accommodates all the future stream of prices, looks like this. This is the price next period, and then expectation forever. Okay. Okay, so we can write this value conditional on development like this, and optimize to choose H. Okay, given the expected stream of future prices,
And this is the sort of thing that comes out in Murphy's job market paper and Peng's job market paper. And from a dynamic problem like this. They have some more bells and whistles, a little bit more complicated than this, but this is sort of the idea. Okay, so this is the optimal amount of H conditional on development, and then once you know that, you can essentially solve for V1, and you can have the development decision. Remember that fixed cost is logit distributed, and so that gives you a form like this for the probability of development. So this can be aggregated across all parcels and can be, take a log and run it as a regression. It can be done in various ways, or maybe if you have microdata, you can do it with maximum likelihood at the micro level. Okay. And what's going to matter is the price of housing relative to the price of vacant land in the end. And sort of in here is the value of development, given that the developer is optimizing how many units of housing services to build. Okay, so basically every one of these, so these recent papers, you need some sort of, we're talking about estimating supply in some sense, estimating the probability of development or the fraction of lots that are developed. And so we need some demand side variation for identification. And that's done in various ways. For example, in Peng's paper, she has variation across New York City that she uses in this way. And then yeah, so I think actually Alvin Murphy's job market paper really got this literature restarted with a model like this that looked at the timing decisions of developers. Okay. So what do people find when they're doing this sort of thing? Well, Peng, she finds that regulatory cost about 25% of marginal and very large, potentially very large fixed cost of development. And where does that come from? That comes from even when developers were allowed to develop with upzoning in New York City, there was very small development response. So it took a very long time for developers to actually respond to this upzoning, which seems to reflect high fixed costs. Okay, that's her model. That gets rationalized as high fixed costs in her model. Okay, and so that leads to very low supply elasticity. Ultimately, I'm going to come back to supply elasticities towards the end. Okay. Okay, these are just further considerations. So let me now talk about another dimension in which the literature has sort of innovated. I think there's a lot to be done on the dynamics dimension. There's a lot of tools from dynamic discrete choice models that we can use to try to improve understanding of dynamic supply. Now I want to think about sort of in the horizontal dimension that housing units are different. Okay. And so the issue is that not all, like we talk about housing services, units of housing services to this point, but in practice we have different housing units, right, that serve different segments of the market, different types of households. And so we want to have some way of modeling that handles this. And the modeling, I would say maybe trick that has been used is so-called assignment models, okay, where you have heterogeneous supply of units of different types, different qualities, heterogeneous demand for housing units, households of different incomes and sizes, and they get assigned in an assortative way, one-to-one. Okay, that's what this assignment literature is thought about, and it's a small literature, but I think it's getting more attention now. So kind of I think probably maybe best known paper here is Landvoigt, Piazzesi, and Schneider, who used a model like this to think about the extent to which demand shocks near the bottom of the housing quality distribution through the credit supply expansion in the 2000s percolated up the distribution of housing quality to raise prices throughout above the portion of the housing quality distribution where these demand shocks occurred, which are really relatively low income people who now could buy homes. Their demand went up a lot, that bid up homes in that segment of the market, and it percolated up throughout the distribution. Okay, that's what their paper argues using an assignment model. Okay, so let's see how this works. We have households of different incomes, W, okay, with, let's start with there's no supply yet, fixed stock of homes, with some quality distribution, and quality is indexed by age. Okay. Households are maximizing subject to some budget constraint. And so given that, the marginal rate of substitution between housing and other goods is going to be the slope of the hedonic price function, where the hedonic price function just tells us what the price of a dwelling is with quality H. Okay. And so since people are choosing how much housing or what quality of housing they want to consume given the prices, it's going to be they're going to consume in this way, given that they're optimizing. Okay. And so each household is doing this, and that's going to determine kind of the shape of the equilibrium price function, given a fixed set of homes that exist to be purchased. Okay. And given a fixed set of households that are purchasing as well, for now. This thing is not necessarily constant, right? So this this marginal rate of substitution is probably going to be more likely to be concave. I'll show you that in a second. Okay. And so given that, it's then unlikely, it's really not going to be the case in a model like this that the price of a unit of housing services is the same for every dwelling. Okay. And so that's kind of right there, I think with that marginal rate of substitution condition, you kind of get some intuition that the framework we were thinking about before doesn't work so well when we have heterogeneous demand and when we have housing dwellings, housing units. Okay. So the equilibrium is positive assortative matching. Okay, so you can think about starting at the top, the highest quality home is going to be bought by the highest income household, and then you'd work down the distribution. And how do we think about that is because the highest income household is going to outbid every other household for the right to buy the highest quality home. And then we work down the distribution of wealth or incomes and housing quality to get to the bottom. And the lowest quality home basically will be, might not even be purchased or used and might have a price of 0 as a result. Okay. Okay. So there's sort of this this single crossing property in the marginal rate of substitution that comes out when you have housing and all other goods, and that's kind of what's driving this assortative matching. Okay, that for a given quality housing unit, higher income households are going to be willing to pay more for it on the margin, so they're going to outbid lower income households, and that's where this assortative matching, positive assortative matching PAM comes from. So here's kind of like how we would build up the price function, the hedonic price function in this model. There's going to be the price of the lowest quality home, and then we're going to integrate up to quality H over all of the slopes of the hedonic price function, given the amount of housing that exists of each quality H tilde that we're integrating up over. That's what the G of H is doing for us. And that's going to depend on the marginal rate of substitution for the W, the wealth level or income level that matches as we move up these distributions. Okay, so it's going to so the equilibrium is going to depend on both distributions of housing qualities across dwelling units and wealth or income. Okay, and so you can get this, you get this asymmetry that comes out that if you get a shock to demand in the bottom of the distribution, that's going to trickle up. That's going to essentially be reflected in higher prices everywhere higher up in the distribution. Okay, because you still have this thing where now, in order to maintain the house quality you're in, now you have to outbid someone who's willing to pay more because there's a demand shock down the distribution. Okay, that's kind of where it's coming from, and that's the Landvoigt-Piaget-Schneider.
I have a question.
Yes.
So first of all, does this assume that there's sorting every period? Because that's clearly not what
There's no dynamics. We're in fantasy land here.
Okay,
So everything here is fantasy
All
land.
right, and the trickle up, I mean, anecdotal evidence in Boston, right? In the late 2000s, when the supply side was relaxed in the lower income areas, the house price increase was much greater in Lowell and Lawrence, the low income areas, than Newton, where I live, for example. So I don't know if there's a trickle up, but it's certainly not proportional.
Didn't go all the way up.
It's not necessarily proportional to the increase in the low income areas, because that was, and then on the way down, right, the biggest declines were also in the low income areas, because that's where all the foreclosures happened as well. So I don't know, how that.
I agree.
Total evidence, I know, but it doesn't. Does that purport with this model or not?
I mean, so one way of explaining what you're saying is the Newton housing market is just totally segmented from the Chelsea, Everett, Lowell housing market. And so there's no substitution between them. And so it's just totally isolated from it. So this is not there on the Newton housing market, right? That's a bit arbitrary, I agree. Like this is a model, this is not, we should always remember that models are not reality.
So then is your example in Boston more typical of what we observe in real life than what's purported in this model?
I don't know. So this paper, the Landvoigt et al. Paper is about San Diego. And there's actually, so I have.
San Diego is even equally differentiated.
Yeah, it could be. Yeah, I don't know. So they and I don't think I need to go through this example. This is just math, but I wanted to get to, let me go here. It just talks about some of the papers looking at these issues. So there is, for example, another job market paper, Betty Wang, she shows evidence that shocks to demand lower down the distribution trickle up. Okay, in sort of a systematic way. That seems to be in the data.
I mean, we haven't masked as the trickle down, right? We also have a trickle down effect.
Yeah, in this model, you don't get that. Except if you build, so this is holding supply constant, right? So if you build more housing at the top, there will be a trickle down. Okay, but if there's a demand shock at the top, that's not going to affect prices farther down in this model. And maybe, and I think there's the question, maybe this model's not going to be useful for looking at a lot of these issues. Okay, but it has been. I think it's what's really hard is that we have this heterogeneity in housing units and heterogeneity in households, and how do we come up with a framework that can handle this all together? Right? Yes.
My impression though is that like these models are really hard to bring in the data, especially
Yeah.
dimensional. I'm curious to hear about like your thoughts on the pros and cons of like this approach versus like say maybe like a more discrete choice kind of IO approach to thinking about.
Yeah, this is like the macro approach, right? And then discrete choice approach. So the problem with the challenge of the discrete choice approach is it can be very hard to do general equilibrium, right? So how do you make sure that all the market's clear when you have all this heterogeneity in demand and people in theory can choose any housing unit, right? How do you make sure that the same housing unit isn't chosen by two agents in that world? That was always I think the Steve Barry comment about the like Bayer, Ferrer, Macmillan work where people are choosing individual houses. That for that sort of world, it's maybe better to have people choose neighborhoods rather than houses, because at the neighborhood level, you know, there can be some supply response, but at the house level, there can't. But this is like one of the fundamental trade-offs we all face is the trade-off between accommodating lots of heterogeneity, which the IO discrete choice approach will do, and accommodating general equilibrium. And it's a tough balance. And so this is the assignment models is one way that general equilibrium is accommodated, but there's really it's all an index. Like there's only one dimension of heterogeneity here. And that's the trade-off that's made. So it's a really good question. And you know, modeling is kind of an art. And that this is one way of doing the art, but it's not the only way. Okay, so there's been a bunch of papers listed here doing this, using this sort of framework. And on the more empirical side, there's been this work looking at moving chains to look at, hey, when new housing is built at the top end of the distribution, how far down does that unit end up reaching in terms of people moving up the distribution? Okay, so when that is, how much of this trickle down is there when you expand supply at the top? And there, I think we have kind of mixed evidence on this. These papers are finding somewhat different things, but at least there's like, I don't know, at least 3 or 4 levels of moving that happens when new housing is supplied at the top of the distribution. Okay. Okay, so let me just, I only have like 15 minutes. So get across, okay, assignment models. That's one way to go that helps us learn something about the operation of housing markets. It's a very kind of macro approach. Then we have sort of dynamic discrete choice type models. That's another way to go. They're going to have a hard time dealing with general equilibrium. Maybe we can do some things, but mostly it's about the developer's dynamic decision of whether to build. Empirically, what we see in the data is there is indeed filtering, okay? That as housing units age, when this is kind of putting these two things together, as housing units age, the people who live in those housing units tend to become lower income, okay? So this graph is for units 0 to 10 years old. The average household income of the residents of those units, and then 11 to 20, 21 to 30, and 31 plus, okay? And filtering is in the data. It's quite stark in the data. And so I think there is this sense that, oh, we do need to take account of dynamic and dynamics and depreciation too, in order to understand housing supply, which goes back to some of the facts I showed you earlier. And assignment models are not gonna, we're not gonna be able to do that at all in assignment models the way we have them right now. Maybe it could be done. That could be a job market paper. That'd be great. Someone of you could do that. Okay, but we don't have that now. Okay, so I think there's been some work writing down what the steady state, what the filtering steady state would look like. And I think I kind of talked about that a little bit. So I don't think I need to say too much. We have about 2% a year decline in income in the typical housing unit. Okay. And I think a lot of the policy world for many years, going back to at least the 80s, I remember hearing John Quigley talk about this years ago, maybe in the 90s, that sort of the main source of housing supply for lower income people is housing that has been built for higher income people decades earlier. Okay, and that's filtered down. And I think we don't have a great sort of handle on this. We can kind of have sort of models that tell us, yes, this can be a nice equilibrium, a steady state equilibrium. And we have some empirical work showing that this seems to occur in the data. But I don't think quantitatively we have a great sense of how important this is as a source of housing supply. But in theory, it could be very important. It could be sort of based on sort of construction cycles in the past. It could generate variation that's quite important in kind of housing costs for different segments of the market. This sort of vintage effect. Okay. Okay, so I think I'm going to say just briefly, yes, there are externalities. With externalities, that's another dimension which we might want to think about carefully and model. Diamond, McQuaid, and Rossi Hansberg et al. Are two well-known papers there. Diamond and McQuaid have a hedonic model where they show that there's willingness to pay in lower income neighborhoods to be closer to new, even low income housing tax credit developments. That's positive, but it's negative in higher income neighborhoods. And Rossi Hansberg et al. Kind of show that you can have this multiplier, that if you redevelop a neighborhood, you can actually have this big positive multiplier through these positive externalities. Okay, so one of the things about housing supply, which I think we could use some more work on, is to think about the fact that there's kind of, you can get stuck in a bad equilibrium where no developer wants to act on their own because the neighborhood quality is low and their development wouldn't be big enough to turn it around. And so basically the demand conditions don't exist to justify any development. But you can have a big push that in theory, if there are externalities, could turn a whole neighborhood around, okay? And this is the sort of justification of this sort of opportunity zone type policy that I don't think we have great evidence that it's maybe successful. I think Jesse might tell us more about this later. I don't actually know, but in theory, it could be true if there's externalities that you can have a big push that coordinates a lot of developers to work together and turn around a whole area and generate a lot more housing supply as a result to get over the undersupply that comes from negative spillovers across locations that are nearby. Okay, and so here's some papers that speak to those issues. Okay. We also, I think we have a lot of reasonably well-identified papers that point to evidence that when you build more housing, yes, prices do go down. So, when you shift out supply, prices do go down. In the policy world, I've talked to many people who are not convinced of that, who think that when you build more, you cause gentrification, it means prices go up and then rents, people get priced out of the neighborhood. okay? Which I think in some cases has got to be true at a very local level, even if it's not true at a more aggregate spatial level. Okay.
People that think that, there's two ways you can think about prices, right? There's the price for the same unit of housing.
Yeah.
That's what this is showing, right? What they see is more expensive housing, but they're more housing. It's more housing services. And so, of course, prices are going up. Newer houses are always
Because you're not holding quality
older houses, right? So prices have to go up. But that's very different than the price.
And actually, I think
housing services.
this is a place where assignment models can help, right? Because low-income people who have a luxury building built next door, it's not surprising they won't like it, because maybe that means their rents are going to go up because of the positive externalities, or maybe even more likely, it increases the probability their rental building is going to be redeveloped and they're going to be kicked out. And so I actually don't think we have a great handle on this sort of phenomenon from in the economics literature. We have these well-identified studies that show, yes, for the same type of housing unit, prices go down when you build more. And now we can take it to the next step. Okay. So for the last few minutes, I want to talk briefly about supply elasticities, return to them where we incorporate the extensive margin, the land development margin of development, which we saw a little bit about, but not much. Okay, so if you remember back to maybe half an hour into the talk, we said there would be this cutoff in fixed costs below which development occurs by a profit maximizing atomistic developer in perfectly competitive world. This is the expression that kind of summarizes what this cutoff will be. And it's going to depend on basically the demand through the price, the cost function, and the cost of and sort of the alternative use, the value in the alternative use for the land. Okay. And so given this, we can then derive what the fraction of land in a market that's developed as the fraction that's below of land with a fixed cost of development below this cutoff. Okay. And so that's sort of one way of thinking about the extensive margin of supply elasticities. Okay, so if we have Cobb-Douglas production, the alternative use is 0 for land, so you can't do anything else with it but use it for development. This would, for redevelopment, this would not be 0. Okay, so I think we can use this also to think about redevelopment. Just Q under bar would be different. Okay, and suppose that the distribution of fixed costs is Frichet with shape parameter, lambda scale parameter, or inverse scale parameter, gamma j. So it's at the market level. Then we can derive a land supply elasticity just by seeing how this fraction of land developed, responds to the price. Okay, and we can work that through. And so with Cobb-Douglas and Frichet distributed fixed costs, it's going to have this form. And you can see that there's kind of this, there's this price shows up here, because that's kind of a depletion effect. So if prices are high, you've already kind of built out most of the land. And so if prices go up more, there isn't a lot left to build on. Okay. And then this gamma parameter is sort of summarizes how thick the tail of the distribution is and kind of how much more land available there is for development. Okay, so this is one way. This is the way I model this in my paper with Lujan about housing supply. Oop, okay, so let me just finish by saying, okay, there's been a lot of estimates of housing supply elasticities. There's Saez's famous estimates, population weighted average 1.6. There's my estimates with Lujan. We do this at the neighborhood level. We find much lower supply elasticities for 2000 to 2010. And then there's Gorbach and Keyes who find even lower elasticities, supply elasticities for 2010 to 2020. So I think we saw that construction is falling at the beginning. We saw that prices are rising much more quickly than they were in the past. That seems like it's not, I mean, maybe there's a little bit of demand on explaining that, but a lot of it is about falling supply elasticities, okay? And so this is a big challenge that we face, a big policy challenge that we face. It is also the case that supply elasticities at different margins are higher, farther away from central business districts. And I think it is useful to recognize that the time scale can matter. So we have the total stock of housing services, which depreciates over some period cap T by delta T, and then gets replaced with this production technology, which depends on this supply elasticity. If we work that through and we say that the cap T is, say, 0.7, which might be a 10-year depreciation rate, I think that's actually quite high, but this is one paper by Greg Howard uses these numbers. So I'm going to use these numbers. That would say that the long run elasticity is about 3 times the 10-year elasticity and about 1.5 times the 30-year elasticity, okay? Because of this sort of the fact that we have some depreciation that's slow over time, and then we can map the elasticity for some time interval then back through that depreciation into a long run elasticity, okay? And even when you do this adjustment, you see falling supply elasticities in the US over time. Okay. Aggregation, we can aggregate these things to the market level from the tract level. And what do you get? You get numbers for unit supply elasticities these days that are something like 0.3 to 0.5 at the market level, quite low. Okay, and so then the very last thing I will mention is there's also very interesting work doing general equilibrium. And as I said before, this means accommodating less heterogeneity, but accommodating linkages between housing markets and labor markets, and especially migration. Okay, so one thing I think that's important to think about is if we saw there's a supply challenge, I think there's a lot of evidence that this might have to do with high levels of regulation. If a metro area unilaterally deregulates, what's going to happen is you're going to have, depending on the population supply elasticity to the migration elasticity, a lot of people moving into that metro area, right? That might not actually be in the interest of the incumbent residents of the metro area, and that's why they don't want to deregulate. Okay, so understanding the aggregate effects of these sorts of policies is going to require having an understanding of kind of the migration responses to improved opportunities, lower housing costs in different markets. Okay, and so Duranton and Puga have a paper where they think about the fact that in an OLG model that there is indeed a sort of a quantified model that there is a disincentive for metro areas to deregulate because actually the supply shock is so large that it's going to reduce the value of the housing stock for the incumbents, and that they don't have an interest in letting that happen, but the welfare consequences for incumbents is very, very small negative, and the welfare benefits for the migrants into these metros is quite large. Okay, and so you can have this problem that local interests are a very strong way through which supply constraints can happen. And so the political economy is such that we get this equilibrium where we have very constrained housing supply. And I think that's a challenge kind of in many different, we see that in many ways. We see that in local jurisdictions that don't want to expand supply. And we see that even sort of at the metro area level. And we have to see it at the national level too, that immigrants coming in and increasing housing costs. That's a big deal in Canada. And that's a big reason why the government was convinced that they needed to reduce immigration, because they were driving up housing costs for people living in Canada, right? So that's a whole other, sort of, in order to think through these issues, we need a general equilibrium framework. And what Duranto and Puga find is that if you were to expand housing supply or reduce regulation in US superstar cities to make it so that they would permit at about the rate of the 75th percentile city, then that would increase consumption by about 2%. But the incumbents would lose out slightly. Okay. And that's a real issue. And I think this is a very active research area of research now, using these general equilibrium models to think about the sort of quantitative implications of different types of supply policies, and then think about the motivation that incumbents in local jurisdictions have for enacting these policies. Okay. And I think there's a lot of evidence that there's some debate about how big the aggregate implications, the productivity implications are of restricting housing supply. How much heterogeneity you put in your model can matter for those conclusions. But it's an active area of research, and I think it's a good topic to work on. Okay, so key messages. Yes, we have a housing affordability challenge. We have declining productivity in construction. Land use regulation seems to be increasing. There's less land available for development. And there's a lot of frictions to development. Looks like it takes a long time for developers to respond to the opportunity to develop. All these, I mean, you can read this as well as me, and I can post these slides because I know I've breezed through a lot of them. So let me just say, what do we want to learn about? I think these are some of the big issues. A lot of work on land use regulation, a lot of work on land availability in the construction process, using dynamic models, dynamic discrete choice models, using assignment models, and thinking about sort of linkages across markets and sort of GE frameworks are all fruitful ways forward to try to address a lot of these issues. And there you have it. So I think I should end there. I know I breezed through the end, but during the break, I'd love to talk about some of these things with all of you. So thanks a lot.
Wait till 11:30. There should be more coffee over there, and yeah, I guess reconvene at